Eh? Yeah? Dave.
Okay. We have to. I'm Dave. Can you hear me? Yes, I'm Dave. Yeah. I'll be taking you guys. It's 101. So please, as you are starting, what's the title of the course code? Yeah, the title.
Introductory Physics.
It's important. Any course you are doing in FUTA, know the course title. You get it? Any course you are doing in FUTA, know the course title, no matter the course. Before we dive, I may guess I already know what physics is. So, yes or yes?
Yes.
You don't know what physics is? It's not a physics new to us.
We are here today to teach us.
I will teach you guys. You know, you have heard physics before.
Yes.
Okay.
Thank you.
Now, our first topic, because this is the school manual and this is what we actually taking you guys. Hope you guys have done the first topic. Yeah, so quantities, units, and dimension. First, we have fundamental quantities. What is fundamental quantities? Fundamental quantities are physical quantities upon which quantities depend for their definition. I'll take it again. Fundamental quantities are physical quantities upon which other quantities depend on their definitions. And they are the basis. We're talking about fundamental quantities, they are the basis. And the basis are length, mass, and time. We have length, we have mass, and we have time. We all know what length is. We all know what length is. You know what mass is. Mass is width. Am I right? Why time? We don't know what time is. So, diving in again, we have derived quantities too. And derived quantities are those physical quantities that depend on the fundamental quantities for their definitions. That is, physical quantities that depend on fundamental quantities for their own definition. Now, examples are now, as I said earlier, derived quantities are those physical quantities that depend on fundamental quantities, and these are the fundamental quantities. That's it. That means that these derived quantities here, they are dependent on these fundamental quantities for their own definition. Example, we have speed. Now, what's the definition for speed? Distance over time. Now, the distance is that. This is the distance. Length. What is distance? If I'm walking from here to here, it's a distance. And just say length. You can calculate the length. Do you get it? That's why it's distance over time. So to get the speed, the beginning distance, that's what the distance I'm going to use to get from here to where this phone is standing, and the time I'm using. I hope you guys are getting something. The distance from where am I to where this phone is, that's the distance, and the time that I'm going to be using. So that's speed. For acceleration is what? Velocity over time. Then we have force. Look at them velocities. Velocity. Yeah. Displacement over time. Thank you. Now, we're having a displacement over time, and that's what acceleration. Displacement is also under fundamental. You get it? And time also is under fundamental. Then we have velocity. So displacement over time is goes from fundamental. That means fundamental is like the basis of the starting point. It's the starting point of a derived quantity. Are you getting something? Then we have pressure. Force over area. What's force? Force. Mass acceleration. Thank you. An area. So if you see this, if you are seeing this, mass is gotten from fundamental. Area, acceleration is still gotten from fundamental. Then length and breadth, the two are still length. The breadth is also length. So you can see that a derived quantity is gotten from fundamental quantity. Are we getting something? Thank you. And if you have list of fundamental quantities and their units, And the unit of length is what? Meter. Because we calculate length in meter. We have time. And time is calculated in what? Seconds. And the symbol is S, as we all know. Then we have mass. Mass is calculated in what? Kilogram. Look at the other one for mass. Another one for mass. Weight. Thank you very much. And the second is kg. So as time goes on, there will be some topics that calculate the mass. You get calculate the mass of so and so and so and so, add it to this, so. It's going to be the unit and then it's kg. Then the fourth one we have electric current. And it's ampere. Electric current. You guys are in is 107 now? Yeah, you know what ampere is. The practical stuff, you guys did it in my and secondary school. Then temperature. Kelvin. We also have luminous intensity. Candela, which is C, D. Then amount of substance. Yeah, D is like in chemistry. Abi? Mole. What else again? What's it like? Jesus Christ. Put that in stress again. So you can see that length, meter, and time is calculated by seconds, mass calculated by kilogram, electric current is calculated by ampere, temperature calculated by Kelvin, luminous density calculated by candela, amount of substance calculated by mole. Mind you, all these things, they are actually rules of someone, not all. The name of someone. When I derived it, when next year now, my brother you can derive some other stuff. What's the name? New York. Your English name? Manuel. You can spell it. Emmanuel's law. Abi, I just want to be a professor. Or a scientist. So these are the scientists that did it, that derived it. I get it. So let's move further. Now we're saying here that dimensional analysis. Dimension of a physical quantity is the expression which shows how the quantity is related to the fundamental unit from which it has been derived. I'll take it again. The dimension of a physical quantity is the expression which shows how the quantity is related to the fundamental unit from which it has been derived. Now let's refer to these three basic quantities of the matrix, which is length, time, and mass. And the length is taken as L. This L is taken, mass is taken as M, and time is taken as T, which is L, T. So if you see this LMT, don't be surprised. It's called length, mass, and time. Am I making sense? Thank you. And the dimension of other physical quantities are obtained from the dimension of these three basic units. I said the other time, the dimension of other physical quantities are obtained from this basis. Now, let's move on further. Like I said, the formula for area. Let us give you guys some few formulas. Formula for area: length times breadth. This is it. Length times breadth is what? Length is what? Length. And why breadth is what? Length too. B is still L. So you can calculate it L squared. Alright. Then velocity. Displacement. Over time. And displacement is what? It's still length. Right? Displacement is also length, which is L over T. So do the calculation. It's called LT minus 1. Okay. Then we have acceleration. Velocity over time. And velocity is what? To get velocity is what? Length and time, right? That is L and T over time. This way is L series power minus 2 because this T is 2 and this L is still 1 here. So the short form of acceleration is LT raised to the power minus 2. Okay. Then we have force. Now, mass is M. And acceleration is what? LT raised to power minus 2. Okay, we need to go more. I'm not getting more.
For acceleration, that velocity per time.
Yeah.
That level of level.
Yeah.
It should be this one minus one.
No, it's because we have it. We have it.
For the upper case.
Remind before you get this LT minus 2.
Okay.
It should be L.
Yeah, just get your seat. Thank you. Let's L minus 1. Write down your seat. Thank you. One time. Thank you. Then acceleration, LT is per minus 2. So the formula for force is going to be MLT raised to per minus 2. Right? Then we also have density. Mass over volume. And mass is what? Volume is what? L raised to power 3. That is yeah, 3 sides, yes, I still know, I still know physics. L, L, L. Yeah. So that's the first length, the second length, and the third length, which is L raised to power 3. I'm going to be L, L, 3. Now this is what I'm doing already, so that you can know where it's starting from. You get it? So you can know the basis of everything. Now, let's move to the application of dimension. It says to derive the unit of a physical quantity, the dimension of volume is L. Therefore, its unit is M raised to power 3. That is, to derive the unit of a physical quantity, dimension of volume is L raised to power 3. That is length raised to power 3. Therefore, its unit is going to be M raised to power 3. That is length is raised to power 3. And the symbol for length is still M, which is M raised to power 3. That is meter raised to power 3. So these two are the same thing. Don't let them confuse you. Do you get? Good. Now, second one says that to check the validity of otherwise or physical equation, the principle is that all terms in a correct physical equation must have the same dimension. That is to check how valid physical equation are. The principle is that all terms of a correct physical equation must have the same dimension. Once they have the same dimension, that means they are valid. But once they are not the same dimension, they are invalid. Let me give you an example. That's velocity. U plus AT. That's formula for velocity, right? To make it more clear. U plus AT. Now this velocity is what? LT raised to power minus 1. And the new here is what? LT raised to power minus 1 plus raised to power minus 2 times times. That is U here is L T raised to power minus 1. And this A here, acceleration, L T raised to power minus 2 multiplied by 10. You can see that they are all to the same dimensions, right? So that's what I'm trying to say. Okay. Now let's move further. Another formula for velocity. LT raised to power minus 1 bracket. LT raised to power minus 1 into brackets. So it's LT plus L. Now, this is another formula for velocity. LT raised to power minus 1. This is the point for velocity. These two here, this is here. The reason why I say two brackets is that not cause confusion. Because everything, this is velocity here, this is it. So it's already together. And this raised to power 2 is with this one. So it must not cause confusion. That's why I said two brackets. Are we together? Then for the other one too, LT raised to power minus 1 into bracket 2 here also. Plus LT raised to power minus 2. Yeah. And this here comes here. Yeah. But then my dad is L here multiplied by 2. L2 plus 2 raised to power minus 1 multiplied by 2 and L2. Then L2 minus 2 plus L2 the reason why this is L2 is because this L is multiplied by this. Are we together? This L multiplied by this. So we have L2 multiplied by L2. Oh, sorry, L is power 2, T is power minus 2. Are we getting something? Now the third one says to determine the exact relationship between measure physical quantities. Let's going to determine the exact relationship between a measured physical quantities. For example, the period T of a given pendulum depends on the length L and the mass M of a bulb and the acceleration due to gravity. As using gravitational analysis, we obtain the relationship between T, L, M, and G. And the T, L, M, and G is what? Time, mass, length, and gravity. Yeah, you guys did in phase 107, the practical, single pendulum. You are going to be using time to calculate it. The mass, the weight, maybe 50 mass, 100 mass, 5 mass, Then we have the length and the gravity. Are you getting somewhere? Yes, thank you. Yeah. Now the formula for the third application that I said is T, which is time, L, X, F, Y, G, Z. And here we are saying K is constant. You know what constant means? Right? You know what constant means? So T is equal to K Lx My. Now, just as we did in the other, when getting the velocity, this z here multiplied by what? By x. So x minus z. Y. X is multiplied by z minus 3 multiplied by z. Now, so equating the indices for L is called x plus z. For M, which is mass, is y. And for time, minus 2z is equal to 1. That is this indices. We all do this now. Sure. This S here, this is the indices here. For mass is y. And for time, minus 2z. And is what? Equal to 1. So now this is the first equation. Second equation. And third equation. Now we said solving equation 1 to 3. We have to solve equation 1. How do we get L to the power? S plus Z. Is the indices now. You're talking about this one. Length. This indices here. Which raised to power x multiplied by dz. Is that clear? Now this is equation 1, equation 2, and equation 3. Now we are asked to solve equation 1 to equation 3. And it gives here y is equal to 0. X yeah, y is equal to 0, x 1 minus 2, then z minus 1 over 2. These are the equations for it. L is 0. Where is that nothing? That don't explain. This y, it has nothing. For x, this is L, this is x here, raised to power plus z here. You get it? Just a simple experiment here. A simple experiment. This y here has nothing. Then x okay, z that with two symbols. We have the x and the z, which make it 1 minus 2. Here also, that with minus 2z is equal to 1, which makes it minus 1 over 2.
Now, does that
That I'm saying, that with two symbols, so that's 1 over 2. That, so moving on, kind now constant L 1 over 2. Okay, yeah. Constant L 1 over 2. And how do you get 1 over 2? From the L. One over 2. Then the n, which is mass. Yeah. This is the formula we are following. Which is m raised to power 0. That's why we have 0 here. Then the gravity, minus 1 over 2, which is z. That's why we have 1 over 2 here. There is 1 over 2 right. X raised to power 0 is what? X raised to power 0 is what? 0. So, K, this F raised to power 0, that's what it is. Not here. Then this G, this is here. Okay, let's break it down. 1/2 multiplied by G. Yeah. You have to multiply by G, that's why you have 1 over G here into bracket 1/2, which is here. Now from the experiment, K is found to be 2 pi and 2 pi 1 over G. That's the answer. Now the second topic, Gabriel.
2 o'clock. Are you going to breakfast?
Yeah.
Okay, so we are done with very much. We are done with the fundamental quantities topic, and now we're moving to vectors. So make sure you have your physics 101 manual and read through it so you can understand better. If you have any questions, just go to the comment section and ask your questions. We'll do well to reply. Thank you. Yours in the legacy.
Now let me drop the number in next. You guys have any questions? Maybe you are rushing. We have another tutorial, Emily, right? Now which is vectors? Now we have scalar and quantities. Sorry, scalar and vector rather. Scalar quantity and vector quantity, right? What is scalar? What is scalar? Scalar is something that doesn't have, yes, that have mass, but doesn't have direction, right? Yes. While vector is something that has mass and direction. Good. Now, see, many physical quantities are completely described by their magnitude expressed in some aspects, expected units only. That is, those quantities are called scalar quantities. And scalar quantities include just temperature, volume, distance, energy, all this, another word, scalar. Why vectors? We have discrete lengths. We have velocity. You have acceleration. And we have force. Although there are more, but for today, let's talk about these ones. Why the main topic is vector. So now, representation of a vector. Vectors are represented by a straight line with an arrow on it. That is, are we determinants? Are we determinants? Okay. Vector is represented as a straight line with an arrow on it. So this is called a vector. A straight line with an arrow on it. Right? Then we have addition of vectors. Addition of vectors means two or more vectors acting in any direction that can be combined to give a single vector which will produce the same effect as the two or more vectors put together. That is, addition of vector means that when you have two vectors put together, aligned together, and they're still going to give the same number or the same how do I put it? Yeah, the same number or the same effect, having the same effect as just one vector. Okay. Then since vector involve magnitude and direction, algebra process and vectors are not the same as an ordinary number. These are two methods of adding or subtracting vectors. That is, we have the geometric and the analytic. Now let's go for the geometric method. Suppose two vectors, which is A and B, are aligned together at angle theta. And these two vectors, 1, 2, are aligned together at an angle theta. See what I'm saying? Their resultant is determined by representing the two vectors by the adjacent sides of the circle, inclined to each other at the angle theta. And the third side, R, is their resultant. This is the third side. And the third side is the resultant. Hence, R can be determined by the cosine rule. And the cosine rule is called R A squared. R squared is equal to A squared plus B squared minus 2AB plus 180 minus theta. This is why we have 180 plus what? Why? A triangle, the total random of the triangle is 180. That's why it's 180 minus theta. You guys get it? So, resultant squared is equal to A squared and A squared is vector 1 plus B squared, which is vector 2 minus 2AB plus into bracket 180 minus theta. So let's say the theta is, let's say theta is 63. So that means that 180 minus 63. What is minus 3? Thank you. Now we just call 117. Still, into bracket. That is what we have. R2 is equal to a raised to power 2 plus b raised to power 2 minus 2ab plus 107. Is that clear? Now for trigonometry method, is cos 180 minus theta cos theta which is r raised to power 2 is equal to b raised to power 2 plus theta. So this is for the geometric method. Why this for the trigonometry method? Are we getting it? Now let's have an example. It says a 12 put together. With force 1080, 1580, inclined, each other. Now find your result and the direction. Of the resultant. Then with force. Now it says here, a toy is pulled by two boys. Just one toy is pulled by two boys with a force of 10 Newton and 15 Newton respectively. And let's say if there are two boys, the first one and the second one, both of them are moving it. This one is having 10 Newton. That is the strength, the force is used to pull it. Why is the other one is having 15 Newton? Inclined at 60 degrees to each other. Now find the resultant and the direction of the resultant with the force 10 Newton. So let's say that the first one is A and the second one is B. Now, the 10 Newton is the vector A. Why the 15 Newton is what? Vector B. Then the resultant Mind you, if you are writing a vector, it must have this symbol on top. So that the lecturer will know that okay, it's a vector. You get. Because those are the little errors the student makes. Now let's move to the topic. To the question rather. This was 10 Newton. He said it's inclined at 60 degrees. This is not 60 degrees. 60 degrees where? Here. The reason why it's like this is that they are inclined at 60 degrees. One. Number two, they are together, they are not apart. Okay. 15 Newton. Now this is 60 degrees. This we don't count. Now according to the formula for finding the resultant is what? R square. Okay. Yeah. A square plus B square. 2AB. Very good. Now, according to trigonometry, if here is 60, here will be what? According to trigonometry, if here is 60, here will be what? No. A straight line is 180, right? So if you are minusing or subtracting the we are subtracting 60 minus 180. What will be left here? 120. That's why we have 120 here. So this is the formula. Now let's put it in. Resultant square is equal to 10 plus 15 square plus 2 times 10 times 15 cos 180 minus 60. Right? What is the time vectors? Right? 10 square is what? 10 square. 100 225 plus 2 times 10 20 300 plus 120. You are looking at why is it 80 and 180 minus 60? I don't want to be confused to you guys. I don't want to confuse you guys. That's why I make it. I broke it down. You get because in the manner it was 120 there is the coefficient. So I divide that by 160 minus 160. So now 100 plus 2 to 5. 3 to 5. plus 300 plus 120.
Minus 0.5.
You can come. Okay. Plus 120.
Yeah, no, minus 0.5.
0.5. Now 320 plus
625.
625 minus oh sorry. Now 65 multiplied by minus 0.5. Minus 3, 1, 2.5.
0.5.
Body mass. Do you know body mass? Like, it's body mass.
Exactly, that's what I'm saying.
Mosquito before addition. There is from here.
Sorry. So now that I was doing class, I see there's any idea. So plus 20, plus 120. Eh? Minus 0.5. Then 100 plus 225. Then 300 is what? Huh? Yeah. Was it 0.5? 175. It's wrong. You should have at 21.8. What is it?
Minus 2, yeah. You like plus.
Oh, thank you. Right. Now, 100 plus into 5 minus 2 times 10 times 15. Plus 20. Yeah, we want it. So 325 minus 300 plus 120. That means we have
Multiply before division.
multiply it. 300 plus 120.
That's fine.
Minus cos 120. 50 cos 120. 50 cos 120. Cos 120. Huh? What do you call it?
Minus 7.5.
7.5. Now, calculate this. Cos 60 is what? Cos 60.
0.5.
Then what is cos 15 cos 120? You should have the exact number. Huh? Yeah. 0.5.
Minus 7.5.
Okay. Now, so according to ten raised to 10 times 7 minus 7.5. Minus 7.5. What is the answer? 21.79. 21.79. Approximately 21.8. Now that's for the first part. Because if you read it here, you're having two questions here. The first one says that find their resultant, and this is resultant. And it says that the direction of the resultant with the force, with the 10 meeting force. Now, direction of the resultant of the 10 meeting force. Before we can find, we are going to obtain sine rule. And sine rule here is R was sine 120 about 15 sine theta. You get? That's for the sine rule. Before we can get the direction of the resultant, we're using sine rule, and this is the sine rule. Now, we cross what? We cross multiply. Then we have R sine theta is equal to 15 sine 120. And R is what? 21.8 sine theta. Then we have 15 sine 20. Sorry, 2 times 120 rather. What are we looking for? Sine theta, right? Right?
Yes.
Yes. So 15 sine 120 divided by 21.8. Now let's see it.
I want to 12.99.
Trust the process.
Now let's calculate it.
Okay, 0.596.
Final answer?
Yes.
No.
Sin theta is equal to
15 times sine 120 divided by 121.8.
86.5.
Very good answer.
86.5.
Now the final answer, when we approximate it, is going to be 36.6. Right? Right? Is what? What is it?
You take them. Are you there?
Yeah. Yeah, since I want to. Do you all get it?
So this video we did quantities and quantities, unit and fundamentals in physics. Then we went to chapter 2 according to our physics manual here at the Federal University of Technology Akure for 100 level physics 101. So make sure you get this manual. Yes, we have the PDF available for you, but you know we can't do the tutorials without the manual. So moving forward, we have done scale and vectors, representation with vector, addition with vectors, geometric methods, and we went through examples. If you check your manual on page 9, you see example 2.1. A toy is pulled by two boys, so and so on and so forth. We have solved that question, and final answer, according to the manual and according to our detailed explanation by our tutor, you can get through to him for more questions. You have the number here. So theta equals 36.60 degrees. So on our next video from physics 101, we'll move into analytic method, and we'll cover analytic method, which is method applied when there are two or more vectors to be added. So we'll go deep on that, and we'll give you detailed explanation on it. So stay tuned to Legacy by Gabriel YouTube channel, and also make sure you use the website where you can get the PDFs, the exam practice, the exam spell, and you also use the Legacy AI to answer your questions if you cannot get through to us. But we always remain Legacy by Gabriel, and we will always get through to us at any time. So we'll go to an analytic method. When we are done with that, we'll move to multiplication of vectors. So we'll do multiplication of vector by scalar, which gives a vector. Vector by vector to yield a scalar, then vector by vector to yield a vector. So we're doing dot product, scalar product, dot product or scalar product, cross or vector product. So make sure you stay tuned and you watch. So after vectors, we move to kinematics. So stay tuned and watch our videos. So keep on watching our videos, and you will realize that this is going to be your best stay in FUTA. Thank you so much. Yours in the Legacy, Gabriel.